So I get a lot of questions from viewers as it pertains to how to visually present their results once they've already generated results and reported them in the APA format. So this video is all about visualization, specifically as it relates to the One-Way ANOVA model. So you've already got your results reported and you're looking for a nice visualization to assist readers with interpretation of your findings. Maybe add a little pep in your step or a little pep in your presentation, poster board, paper, etc. So as always, all code related to this video's exercises can be found within the video description below, along with an associated data file. But we're not doing a data file this time. We're actually just going to create our data frame right in R. If you're having some trouble seeing what I'm laying down here, feel free to turn up the video quality. And if I'm speaking too slow, maybe watch it at an accelerated speed. So let's get started. We've got group and we've got observation, and these are going to be our data vectors. Again, you can find this in the video description below, so you can go ahead and run this bit of code, and you should have some vectors show up on the right-hand side if you have RStudio installed. If you do not, there's a video on that in the playlist. So we've got group and we've got observation. Now, group is going to be our factor variable, and observation is going to be the observations associated with each. So I'm going to use the function data.frame, and we're going to bring in group, and we're going to have observation in there as well. And we're going to use that to create the ANOVA, all caps, underscore test data frame. So I'm going to run this code. I have mine keyed up with hotkeys, but if you're doing this at home, you can just click run. And there we are. So let's take a look at this because your data has to be structured in a certain manner for any of this to actually work as far as creating visualizations is concerned. So here on the left, we have the group or the factor variable, and we have groups A, B. Oh, I don't know what's going on there. We have groups A, B, C, D, and we have the corresponding observations, 3, 6, 2, so on and so forth on the right. All right, so let's get out of there. So in order for any of this to work, again, our data has to be structured in a certain manner, but we also need to have these appropriate libraries here. We have to have these installed and initiated. So if you haven't installed ggplot2 and gplots, go ahead and get those downloaded and installed. And if you need help with that, there is a video in the playlist which will assist you in doing so. So let's go ahead and get these libraries ready to go. I'll run it right here. There we are. So we have these initiated, and now we're ready to create our visualization. So I'm going to create the first visualization here. I'm just going to run this code. I'm going to create the visualization, and then I'm going to go over each portion as it relates to what is achieving what. So let's go ahead and run this code, run it. And here is our visual. So let me just go over each portion of it, and hopefully you'll be able to then at home change the portions of the code which relate to your data frame and create something similar for yourself. So here we have the ggplot function, and you need ggplot2 for this function to be utilized. So we're going ggplot2. This is the name of our data frame, so change this to whatever the name of your data frame is. Our data frame is ANOVA underscore test. This is going to be your data frame. X is going to equal the group variable. So our group variable is named group, but if your variable is, I don't know, watches or cars or something like that, make sure you change that to reflect whatever the variable name is within your data frame. All right, and that is going to be our x-axis, as you can see down here. So A, B, C, D, it is the group. Y is going to be our y-axis. This is our observations contained within each group. So ours is easy. Again, we just have this named observation. Yours may have a different name. All right, maybe it's miles per hour or miles per gallon or something like that if you're dealing with automobiles. So make sure your y-axis variable is appropriately reflects the name of the variable within your data frame. So data frame, x-axis, y-axis. Color equals group. This is going to tell R as it relates to this particular function here, that we want each particular group in our output to have its own color. So here, because we specified color equals group, X being our group variable, so color equals group, group is our X variable, all right, or X-axis variable. Color equals group means that we want each group value, each value on the X-axis, A, B, C, and D, to have its own unique color. So we have A is red, B is green, C is blue, and D is purple. Now shape equals group, group again being the value which is found on the X-axis. Shape equals group, and you'll have to change this to whatever your data frame is for your needs, your data frame variable. That is telling this particular function here that we want each output value on the X-axis to contain its own shape. So here, A is circles, B is triangles, C is squares, and D is crosses. Okay? And it's the color equals group that provides us with the unique color for each value on the X-axis, and shape equals group provides us with a unique shape for each value on the X-axis. And again, it's on our X value, our X-axis value is group. And you'll have to change this to whatever your value is, your grouping value, your factor value on the X-axis. All right? Now just leave this be. Code is in the video description. Leave this be as well. You don't need to play with this at all. And this is placing, this right here, this is placing the legend. So we wanted to put a little legend on the right there, just so drive the point home. Now, if you don't want this in your output, if you want this out of your visual, you can just change this to none. Now, if you want to take a closer look, you can just click zoom. If you want to, if everything looks okay, once you've examined your visual, you can export it, save as image, and then take that image and add it to your research, your paper, your presentation, whatever it is that you're working on particularly. Now we're going to create another visualization. So let's get out of this by clicking the broom. The next visualization we're going to create requires library gplots. So we have gplots ready to go. We have it initiated. We have it downloaded. And what we're going to do first is we want to take our grouping variable, all right, or our factor variable, and we want to actually make sure that it is stored as a factor within our data frame. And we're going to do that by placing the name of our data frame, the $sign, then the name of our factor variable, and it's going to equal factor, and then within this function, it's going to be the name of our data frame, $sign, and then the name of our factor or group variable. So you'll have to change this to whatever your needs are for your data. So we run this, and now we can proceed. Plot means is a function which is native to the gplots library. So again, you need to have this working for this to work. So plot means that we're going to use our data frame name, $sign. This is our variable observations. All right, so this is our continuous variable here. This symbol, which is shift, and then it's the key to the furthest left on your keyboard. And then this is the name of the data frame again, $sign, and then the category or factor variable. So I'm just going to run this so you can see what's going on, and then I'll go over what's happening. So here we have our X-axis values, our groups. N equals the number of observations in each group. Okay, so there's 15 observations found within D, 22, in C, 25 in B, 25 in A. And these dots are the mean values. These are the mean values of the observations. All right? So these are the groups, and these are the mean values of the observations in each group. So there were 15 observations in group D, and the mean value is, looks like somewhere around, or maybe slightly above 6.5. So when you see this here, XLab, this is assigning a label to the x-axis. So I guess we're operating under the assumption that these are watch types. So this could be whatever your actual, these values are representing along the x-axis. So maybe you want to place a x-axis label there in addition to the values on the x-axis. And \n is saying, give us a new fresh line. So we want a new fresh line here. Otherwise, this will all be on one line. It'll be watch types, and then immediately error bars, 95% confidence interval. But with \n, we're saying, give us a new line. And on that new line, and you can change this as you'd like. Maybe you don't want to have this in your particular graphic. We're stating error bars, 95% confidence interval. And what this is informing our reader of is these values, the dots, these dot values are the means, and these blue lines represent the confidence interval at 95% as it relates to the values contained within 95% of the confidence interval of the mean. Y label is observation. You can see that here. You can place whatever title you want here. I have it as place your title here. You can, if you want a title, you can place that. If not, just delete this line in its entirety, and you will no longer have a title. PCH equals 16. That is informing our function that we want these to be solid dots. The normal dot type is open dot, so it's just a round dot with no core. And I don't think that looks very nice. So PCH equals 16 is telling us we want solid points for our mean values. So again, you can take a look at that by clicking zoom if everything looks okay and you want to include this for your research needs. Go ahead and export that, save as image, and do what you like with this particular visual outputs. You could use both visual outputs in your research. You could use one or the other, or you could use neither, whatever you're comfortable with. But make sure you also have your results reported in APA format. And I hope that this provides you with a little extra oomph as it relates to presenting your findings to your readers. And you can do additional research on your own if you'd like as to how you might change these functions up if you wanted to add or remove some additional attributes as it relates to your graphics. And those particular functions can be found within the ggplots2 package or the gplots package within R. And so that's where we're going to leave off for today. If you enjoyed this video, please consider liking and subscribing. Again, the comment, feel free to leave a comment, and the code can be found in the video description below. If this was able to help you out, please consider liking and subscribing, because we're going to try to get this out to as many users as possible. So best of luck in your research, and thanks for stopping by. And until next time, take care.